table. Okay, so when we're talking about the periodic table, we're going to break down a few key things. And this is your learning intentions from the very start of your booklet. We've just broken them down a little bit further here. So let's have a read through these together very quickly. You're going to be able to, by the end of today's lesson, to name the main groups, and what we call groups are the columns in the periodic table. And there are some key groups, and these are what we're going to be using our colours for. So maybe I might start using my colours now to represent these. So I'm going to use yellow for the alkali metals. I'm going to use green for the alkaline earth metals. I'm going to use blue for the halogens. And I'm going to use purple for the noble gases. Okay. From there, we are going to determine, using the periodic table, the number of valence electrons in the main group elements. We should be able to determine that the periodic table is arranged in order of increasing atomic number. Okay. We need to, thank you very much. We should be able to relate the arrangement of elements in the periodic table to their electron configuration, another idea that we explored in our last lesson. Hopefully we're able to state the main groups of the periodic table. So remember, the groups are those columns from the first dot point. We'll talk about them in a second. And how they represent elements with similar chemical properties. Okay? And what we mean is similar characteristics, right? Finally, locate the position of an element based on its electron configuration. So a couple of key things to jump out here. Firstly, groups of the periodic table, valence electrons, electron configurations. They're all going to be important ideas. So let's jump down first to groups and periods. The periodic table, as yours has been labelled, is arranged in order of ascending atomic number. What that means is we go from atom 1, hydrogen. You don't need to highlight these right now, but element 1 is hydrogen, element 2, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, blah, blah, blah. So as we go up in the periodic table, we increase each time by 1. And what does that increase of 1 mean? What does it actually mean? There is one more proton in the nucleus each time. So what we're going to do now, the periodic table, as we've said, is divided up into these two groups. We have the columns going down called groups, and we also have the rows going across known as periods. And these have been marked on your page already. Okay? When we have a look at your page, you'll see that we have all of these different groups running along the top. And if you look down the very bottom left-hand corner of your page, you will see this word periods. And periods is referring to these 7 periods here. So here's what we're going to do. I'm going to very quickly annotate the top here to show 1, 2, 3, 4, 5, 6, 7, and 8. These are the 8 groups that we know about in year 9. Can I ask that you please don't do this on your normal periodic table? Our normal periodic table, we're going to do something slightly different a little bit later on. So this is just this one on page 18 of your booklet. So 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 groups. Now, this is a slight lie, okay? And if you look at one on the internet, you'll see that there are 18 groups in the periodic table. Where do we get the other 10 groups? They come from these transition metals. So in reality, it actually goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so on. So all we've done really is take the 1 away from out front of those. Okay, so if you see another periodic table on the internet in your own private studies, don't freak out. But as of here, at St. Mary's in year 9 and 10, all you need to know is the 8 groups here. Okay. So let's start by highlighting them as we have done up on our previous page. So the first group of the periodic table is a lot of fun. Okay, a lot of fun indeed. And it is known as the alkali metals. These alkali metals, as you're going to highlight for me now and colour in on your own periodic table, include everything from hydrogen all the way down to francium. Okay. So just that first column, that first group of the periodic table, can you highlight all of those elements in the same colour? Okay. Now, all of these elements, this is what I need you to know, are known as the alkali metals. Alkali metals. So again, you only need to do this one on just page 18 today. Okay. The second one, okay, just to the left, and I'm just going to double check my colour scheme here in green. The second group is known as the alkaline earth metals. So very slightly different, alkaline earth metals. Okay. Now these alkaline earth metals are very similar to the alkali metals, but the only thing that we need to know is that they are slightly less reactive. So for instance, if we have a look at number 4, the fourth period, we look at K. And you may or may not remember that K is potassium. Potassium is very, very reactive. If we add potassium to water, it will explode. Okay? If we move one over to calcium, calcium will still react with water, but it's not going to explode. Okay? It's not quite as reactive. So these are the most reactive. We get less reactive. We then go through this really big group, and I'm going to encourage you, I haven't actually highlighted this in any colour when we went through our notes. I'm going to use bright pink, something different, and you can already see me having done that previously. This is to represent the transition metals. This group is all metals. So far we've only spoken about metals in the periodic table. Okay? We've started with really reactive metals in the alkali, slightly less in alkaline. And then by the time we get to the transition metals, they're much less reactive again. So some example of transition metals include these ones here, Ag and Au. They are what we call silver and gold. Now, if silver and gold were very reactive, they wouldn't make good precious metals, right? So for instance, my wedding ring, if my wedding ring was super reactive and it reacted with water or reacted with air, my finger would blow up. Okay, and my hand would blow off every single time I put my ring on. I don't want that, right? I want a nice stable metal that won't leave me permanently disfigured. So this is why I don't use, say, potassium or calcium for my ring, okay? And I use a really stable metal like silver or gold. You're right, we do eat potassium, we do eat calcium, we eat magnesium, sodium is in our salt, but we don't eat the metallic version. We eat something known as the ionic version, something that we'll talk about in our next lesson. Okay, so yeah.
If you crush up like a nutrient and you put like a metal bits come up,
No, because they're not in the form of a metal, they're in the form of an ion. Bananas, yeah, they do have potassium, okay? However, the potassium is bound to something else. It's dissolved, okay? So our next group, everyone, that we're going to move on to is our halogens. Now, I'm going to represent these in blue. The halogens are our group 7 elements, okay? Group 7.
what's the 3, 4, 5, 6?
So they are located in the second last far right-hand column of the periodic table. Second last far right-hand column. And they are right next to our final group, which I like to use purple for, called the noble gases. And the reason I like to highlight them in purple is because purple is typically associated with being a royal colour. Okay? And these noble gases are like royalty on the periodic table because they have complete valence shells.
What's that?
Complete outer shells. They don't need to bind or react with anything else. They are happy as they are. What we're going to do now is we are going to draw a little red line. I've got my red pen ready to go. And what we're going to do is we're going to draw a line to separate all of the metals and the non-metals in the periodic table. So what we're going to start with is we're going to draw a line just above aluminium. And this line above aluminium then extends down past gallium, okay, beneath germanium, okay, and then down past antimony, okay. It then extends next to tellurium and then just down before it ever gets to polonium. And so everything on this side of the periodic table, if I draw an arrow, is what we refer to as, I'll make my pen a little bit smaller here. Sorry. These ones on the left are what we refer to as metals. And everything to the right of that line is known as a non-metal. Okay? So we can divide the periodic table up into two main groups here, metals and non-metals. Okay. So can I get you to please make sure that that line is really clear on your periodic table? I've used a really thick line here to make sure it's clear, but I want to move around the room and double check in a minute that everyone's is really nice and clear as well. So, when we talk about the group number, what are we going to observe? What are some things that might stay the same? And I want you thinking about electron configuration. What is going to stay the same as we stick around in a particular group? So maybe if I get everyone to put their finger on the halogens right now. So put your finger on the halogens, group 7. In the outer shell of all group 7 elements, they are always going to be one away from having a full valence shell, a full outer shell. If we jump all the way to the opposite end of the periodic table, so we put our finger on the alkali metals now. All of these elements have how many electrons in their outer shell? One. Okay. So, state what the group number relates to. Your first question here, well, the group number relates to the number of valence electrons. So let's write that together. The group number relates to the number of valence electrons. And so let's use that example of the alkali metals now. So in brackets, e.g., all group 1 elements have how many valence electrons? Great. Have 1 valence electron. Question?
If the outermost shell is one of the shells that you fit like, because then it wouldn't be like...
So the only real one that has 2 is this first shell, okay, with hydrogen and helium. The reason that the fourth shell only has 2 is because we stop at calcium, right? We stop at the 20th element. The reason that we stop is when we then get into the transition metals, okay, the rule no longer applies and the rule changes. Okay? So in year 9, we sort of tell you half-truths and we fill it in halfway. We don't give you the full picture because the rule no longer applies. Okay, so this works perfectly up until the 20th element, calcium, but after that it stops working.
So you said that the ones at the end of the group X are known gases because their shells are fully filled up.
Mm-hmm.
Their outer shells.
And the outer shell for helium, for instance, has 2. The outer shell for neon has 8. The outer shell for argon has 8. But by the time we get to krypton all the way down to radon, for instance, their outer shell is full, but it doesn't have 2 or 8. It has a completely different number, which you don't need to know. Question? Sure. Okay. Yeah?
With the 7th one, so it's 1 away.
1 away from that full shell. So it just needs 1 more electron. All have different numbers, but they're 1 away from being complete. Okay. Our next one, okay, is what does the period number relate to? So if I very quickly draw a line, the period, as a reminder, is everything that moves horizontally across the periodic table. And if we have a look at this periodic table, how many periods do we have in the periodic table? We have 7. We have 7 periods, 7 rows going across the periodic table. So what do these rows tell us? Well, this first row, hydrogen, helium, tells us that how many electron shells does hydrogen and helium have? 1. If we move down to lithium, how many electron shells does everything in that row have? 2, the next one, 3, 4, 5, all the way down to 7. So when we're talking about what the period number relates to, the period number is the number of electron shells. Okay? So if we were to pick an example of this again, we could pick an element. Let's maybe pick an alkali metal as we did the first time. We have a look, and the alkali metal I'm going to pick is potassium. So for example, potassium, the symbol K, is found in period what? 4, and has 4 electron shells. Okay. So when we talk about the group number, it tells us how many electrons are found in that valence shell. When we talk about the period number, it tells us how many shells there are altogether. Okay. So what I'm going to get you to have a go at now is question 3. You're going to need to use the periodic table to answer these. We'll go through the answers in a minute. But can I ask you, can you work with a partner now? Can you go through and complete all the way down to K for me, please?